Okay, guys. I will start just correctly the name of this file here. I put E at more here, but I correct it right now to vector star. So we will start create your first agent using a separate file. This is something important for a couple of projects that I've been done. I try to isolate and get the single responsibility for each file, for each agent here, using the LangChain to manage all the agents that we will have here. So we will call that Petshop, and we will start import the structure called base-tool responsible to be able to create an agent here to work with LangChain. So from LangChain tools, import base tool. The characteristics of agent here, it's called as a tool. So we will send for you an open question from your customer or user here, and the agents, the LangChain will be responsible to change the best tool for that kind of answer. So that's why to construct this kind of structure, we call it as base tool. So let's start create a class here. So the class name will be search products by description. Let's call like that. Then we will receive the base tool. Okay, so the most important of the structure of the tool to the LangChain, the first prompt engineer responsible to understand the best tool, we will need a name. So the name will be a string that will receive the search products by description, same name here. And also we will have a description. Description will be so important because through then that will be responsible to understand it's the better agents or the better tool to answer the question. So I will open a string here and I will put find pet products based and categories example best shampoo for dogs with a sensible skin. So we can set a couple of examples here. Spoken a little about the prompt engineer. This case will be only instructions with 0 shots, just the instructions that we like from this tool. So it will be easily to do something like that. I will put a little broken line here, but after that I will do a backspace to return off the broken line because they make importance on this agent will be read for choose the best tool that we will have. So just to be more flexible to you guys understand. So interactives toys for baby cats or for puppies, right? 5 best products for dogs mental clean. So this will be a resume a description of your tool here, right? So you can give some examples as an instruction and some couple of rules. The input must have a clear sentence with the desired product. Okay, return 5 products with name, price, and a short description. So as a prompt engineer, it's just instructions for our tool here, or agents, and it's important to define the rules, how the answer has to be in this situation. So let me organize here. Okay, so first will be the description, and after we will have two rules from this agent. Okay, so we will define the init here with the most important variables that we will use. So as a class, they will receive self and quarks to be able to pass in the future if you'd like a dictionary, if some rules and other variables, because we have to change a little about to be able to receive quarks and to receive, for example, to use another variable as a global variable here inside this class, because the base2 has a restrictor kind of class here, so you have to use some couple of chains in your code. So receive cards here. Okay, for do that, you use the super to change the rules in the restrictor of your class base2 to get a unit with quarks. Okay, after that we will select the embeds, and with embeds we will get the OpenAI embeds. So from LangChain embeds OpenAI, import OpenAI embeds, we receive the API key, and you get the OS with get env OpenAI API. So we have to import EOS, and also from .env import load.env. Okay, so let's define here in the init of this class the vector star with the face, and we receive first less from LangChain vector stars import face. Okay, and to be able to using this class as a global variable, even using the base2, you will use the pydantic, and we will import a private attribute. We have a couple of ways to do that, but to change the rules of the base2 and to be a little less restrict, I like to use this kind of global variables using the private attributes. So for do that, you use the pydantic as a library to help us with this kind of class with more restrictions. So I will pass the private attribute here. So now I will be able inside the init of your class using the self dot vector star to be able to access in another function inside this class. So you will receive the face with load local. In the last video we find out how you can save a vector star outside of your project to be able to have an answer of artificial intelligence more fast, to be able to look for the semantic of or open question that we receive. So it's a good strategy. If you don't see the video, go into last video to understand how you can manipulate and manage the vector star. So the name of the vector star is FAISS index. We receive the embeds here. Yes, because I have to deserialization these all the embeds that we send for us. And to be able to do that, we will use action here inside this function in load local to allow dangers deserialization here as a true. This kind of situation is just somehow some way that you can have more secure inside your embeds to not allow directly any embed comes from the internet, you know, that not can be yours index or your vector star here. So this is a situation that we have, so we have to pass this attribute here in the function to be able to restore the vector star that we did before. It's okay. So right now we can develop the main function here. This function we call it as search products, and inside the search product we will receive the structure of the class. We also will receive input here as string, and we will put a strategy of retries as an integer with partner. It's the full value here as 1. So this will be the inputs that we will receive in this function, and we will start here with the maths. Maths will be the retriever from your vector star. So they will receive the vector star, the variable that we created before, with the similarity search based on input that we receive. And well, let's put the key here will be the number of results that we will receive. So every that we have the k is the center of clusterization, so will be related to distance here. So we will put the distance with a 10 of the returns of possible matches that we will have. We have the context to be responsible to get the context inside of your prompt engineer here on the search product. So the context will receive a block of line in the beginning with a join for m page content for m in maths. So it's look like Google some research. So for any page that we have here inside of our vector star, iterate them to get a context, organize the structure for the prompt engineer, and we'll be able right now to get a prompt text, and this prompt text will be more basic. So the prompt text that we will use here, will be a complex prompt engineer. We will pass directly instructions, similarly with the descriptions, because the way that we will create this application, we'll be using the ReAct. ReAct is just look like a kind of a strategy to use the reasonable and act. So understand the question, understand the best agents that we could possibly have, and after that you do the action. It's just look like work as a chains of thoughts. You know, when we speak about the prompt engineer, this is important. If I don't have this kind of situation to use the ReAct here, I will try always to use chains of thoughts. When you pass for the prompt for the artificial intelligence, the ability to understand example, you know, for example, 1 plus 1 it's equal with 2, to be able to the artificial intelligence understand the way that the K resolve all the structures necessary to give you an answer, a clear answer for the user. So if I'm not using here the strategy of ReAct, I will try to use the chains of thoughts inside my prompt engineering, right? So you are an assistant that helps pet caregivers find the best products. The database only these lines exist. So we put a rule here to mitigate the hallucinations that we possible have here. So I will pass the context, the variable here to get my embeds based on a related search of the input from my user, right? So user said input your task, return up to 5 products strictly from the database above. Okay, for each product provide product name, category, price, and a short description. And another technique to mitigate the hallucinations: do not invent products that are not in the database, right? To be more restrictable possible in this kind of situation. So this is it, I guess. Right now, you use the prompt template, will be responsible to generate the chain of the base 2. So for each base 2, we have a prompt template, and after that, we will invoke a LLM application to use here. Let import from LangChain prompts, import prompt template. Okay, so the prompt will be receive the prompt template with input variables, input and context, and that will be the template, the prompt text. Okay, so template, input variables, it's okay. The prompt template, I guess this is it. Prompt template. So let's deliver the prompt and also the LLM. So I am not already give the LLM here. So the LLM will be the chat OpenAI from LangChain. OpenAI will be import the chat OpenAI here. The model will be the GPT-4. Okay, and the API key is the same as the OS get env of the embed here. products. Okay, so right now we have a prompt here with the prompt template. We also has the model that we use in this chain to understand is the better question, understand the semantic here, using the power of artificial intelligence to get the right answer. So this is will be the prompt. And right now we will have an answer here with chain invoke the input. You receive the input here, and the context, we receive the context, and we will deliver the content of this answer. Okay, in this function we will return the answer for the user. Okay, so right now we have the main core of your function here to search the products. We need to follow the structure here from the base to a run function. So the run function will be responsible to unify all functions that we have here with all the important variables to get the answer from the customer. So they receive themselves as a class, the input as a string, and also the max retries as an int with the default value as 1. We have the results with self search products, right? And deliver the input here and return the results. Yeah, I guess this is it. This is structure, but to understand if everything goes well, we have to create another two files, to manage all the structure of this agent to understand how will be the responsible to understand select the tool, the right tool or the right agent, and also a simple file, a main.py, to be able to run this application. Okay, so let's go create your agent file here. You'll be responsible to understand the best tool that we could possibly have here to get the answer. We will start with a class, call it agent OpenAI functions. We receive the init of the class to start. We receive self. Inside of the self, we will have the LLM. So the first import will be from LangChain, OpenAI, import the chat OpenAI. So they will receive the model GPT-4 and the API key was getInf. Similarly with that, it's okay. So we have to import EOS. Right now I will give the class, so products by description. We receive from your file, call it Petshop, import, get the name of the class, they not declare directly, so we receive the search products by description, the name of your class. Right now we will start a variable called tools, we receive the first tool here. So to be able to use the tool from LangChain, agents, import tool, and inside of this tool we will give the name of them. So products by description dot name, the function, the main function here to run this class, so will be products by description that run, and description will be products by description dot description. So if you'd like add a new tool, for example, right now I'd like to get the availability of the bath schedule here, I can just put another tool here. So I will generate another file with the bath availability, create the best functions here using the strategy that I'd like to try, and I can put new tools here in this application. So this is the way that you can use the LangChain to work with agents. So it's pretty simple. It's a great tool here to use like that. So this is the kind of way of with you can work as agents. So let's continue. Let's get the prompt here. Is another way that I suggest for you guys. We have inside the LangChain, the community they call the LangChain Smith. We have a lot of prompt templates already available just to use here in your applications. So we have the ReAct template prompt style here that we will use to be able to recognize the best tool or the best agents for each open questions that we received. So to do that, we use the RUB, yeah, and inside the RUB we get the pool. From LangChain, we can import the hub, and this is the community from LangChain. This is the prompt template that use the ReAct, like I said before, so it'd be able to understand for each tool, for each agent that we have the best mix of structures to give an answer. Here use the chains of thought is one of the better structures to reasoning to be able to work with artificial intelligence with intelligence way. So the chains of thoughts receive an example, so they give the action, how we can talk about. So this is a structure exactly that we need. It's pretty simple to use the kind of structure here using the LangChain. So I will return here in my agents and pass the name of this structure. You'll be able to generate by your own if you'd like to pass some details for your company, but I suggest you use a prompt template. It's great to understand that we have this this possibility to use something from a community, but you can create your prompt template here to be able to access these tools. So right now they will receive the self agent here, and we will use create ReAct agent. So this will be our structure to use the ReAct. So you receive the LLM, receive the tools here, and also the prompt. Okay, we have your management from agents here, and let's create another file here called man to execute this agent, right? So to see if everything goes well. You will start import from agent, your file that we create right now. You will import the agent OpenAI functions here. Okay, so you will start call the agent. So will be the agent OpenAI functions. Also, we have the executor. So the executor you receive from LangChain agents. I will import the agent executor, and we receive the agent executor here, and inside the agent executor we will pass the structure of the agent. So it will be agent.agent. We'll pass the tools. This is an equal here. You'll be receive the agent.tools. Let's put the verbals to understand how the artificial intelligence will think. So let's put a true here, and let's put a handle parsing errors to understand the logs that we receive. We receive a true here. So we will have an answer to executor. Will be invoke the input. You receive the question here, and the question will be the best toy for a anxiety dog. Let's put that way to see the return of this message. Let's give a print here from the output of this artificial intelligence, the output of this executor. So I guess this is it. So another thing that I have to pass is I have a lot of this is a kind of file that connected another files like the Petshop and agents that have to be able to see the environment here. We not declare directly the environment here, but if I have another file that will be executed, it's good that load the environment that we have before. So from .env, we import the load.env, and let's pass there, and let's see the errors that we will have. It's probably will have a lot of errors here. Let's see, execute the man.py. Petshop, I made a mistake in this, in the agent here. Petshop, it's okay. Private are from Pythonic can import. So let's see. I get the wrong here because it's tutus. So I did a mistake here. Let's execute again. They enter the agent executor chain. This is how we speak about the chains, right? So the chain is the unify. It does look like a graph in that we have another framework called LangGraph, because you can put a lot of executions directly, one before one, another one directly, and it just look like a graph using as in the pipelines of data engineer and machine learning engineer. So the chain here is the unify of the LLM with my prompt template as we see before. So let's see the another error that we receive. Input variables it's not defined. Let's see. So in the pet shop. So this receives a echo. Don't forget that I will leave the code here of the end of code with not these errors or mistakes in my GitHub here, and also in the descriptions of this video. So look in that to get the right answer. But let's debug here, name LLM, and line 69. Okay. It's equal here. This is the true life, a lot of mistakes that we did when you program this kind of application, right? So I guess you feel my pen here. Let's see. So I get the question. Content will be contest, right? So pet shop here, line 62. Here it's a dot. So a contest here, we receive, okay, and I have a content. Let's execute again. Oh, now I give the answer. So the enter with the agents responsible to get the best toys. So this is the answer. So interactive toy, pet ball, round pet games, a quality and durable toy that mentally stimulates your dog, aiding anxiety relief. Oval toy, an interactive oval toy, sea patch orange, highly hated for engagement, satisfying your pet's needs for a mental and physical activity. And this is the price for any toy. I guess is a little bit expensive here. This kind of toys. This is a data set that I have from the scenario from the Brazil. So I guess the price is in reais, it's not in dollars, but you can see how is the output of this kind of an application. It's a good application, and not enders by here. It will generate a simple Streamlit front end to use with this application.